Learning objectives. We will discuss the following topics in this chapter. Introduction to AI languages like LISP, Common LISP, Prolog, Visual Prolog, Artificial Intelligence Markup Language, Java Expert System, Java Expert System Shell, etc. Introduction to Prolog Programming. Anatomy of Prolog Program. Classes, facts, goal, variable, predicates and rules. Unification and backtracking. Lists and recursion. Arithmetic and comparison. Fail and cut predicates. Introduction to AI Markup Language, AIML. It is a XML-based markup language and it is a tag-based. Tags are identifiers for the responsibility to enable code snippets and insert commands in the chatbot. AIML defines a data object class called AIML objects, which is responsible for modeling patterns of conversation. AIML objects are language tags, and each tag corresponds to a language command. The general form of an AIML object or command or tag has the following structure. Open command, list of parameters, close command. An AIML command consists of a start tag command, a closing tag command, and a text list of parameters that contain the command's parameter list. Introduction to Java Expert System Shell, JESS. Atoms. The atom or symbol is a core concept of the JESS language. Atoms are similar to identifiers of other languages. A JESS atom can contain letters, numbers, and the following punctuation: $, asterisk, equal, plus, backslash, lesser than, greater than, underscore, question mark, hashtag, etc. An atom does not need to begin with a number. It may begin with some punctuation marks. Some have special meanings as operators when they appear at the start of an atom. The best atoms consist of letters, numbers, underscores and dashes. Dashes are traditional word separators. The following are all valid atoms. FOO, first value contestant, #1 underscore ABC. There are three magic atoms that JESS interprets specially: nil, which is somewhat akin to Java's null value, and true and false, which are JESS Boolean values. Numbers. JESS parses only simple floating point and integer numbers. It does not accept scientific or engineering notation. The following are all valid numbers: 34.5.643. Comments. Programmers' comments in JESS begin with a semicolon and extend to the end of the line of text. Here's an example of a comment: colon. This is a list ABC. Comments can appear anywhere in a JESS program. Strings. A character strings in JESS are denoted by using double quotes. Backslashes can be used to escape embedded quote symbols. It must be noted that no such similarities can be found between JESS strings and Java strings. At first, no escape sequences are recognized. For example, you cannot embed a new line in a string using /n. On the other hand, real new lines are allowed inside the double-quoted strings. They become an integral part of the string. The following are all valid strings: foo, double quote, foo, hello world, backslash, nonsense, comma, backslash, double quote, he said firmly, double quote, hello there, double quote. The last string is equivalent to the Java string, double quote, hello, comma, backslash, and there, double quote. List. Another fundamental unit of syntax in JESS is the list. A list always consists of an enclosing set of parentheses and 0 or more atoms, numbers, strings or other lists. The following are valid lists: +32 ABC, hello world, defemplate, foo, slot bar. The first element of a list, the car of the list in Lisp parlance, is often called the list head in JESS. Introduction to Lisp. Syntax. As an expression-oriented programming language, a common Lisp program consists of either expressions or forms. Though a form itself is a program, most programs are made up of many forms. There are three kinds of expressions. Symbols. Symbols are Lisp's variables. Name of the symbol may legally contain many characters, but are usually made up of letters and dashes. For example, a symbol. Lists. Lists are diminished by parentheses. For example, fxy contains the symbols like f, x and y. Lists are Lisp's function calls. Evaluating fxy calls the function named f on the arguments x and y, whatever they are. Literals. Literal expressions include numbers. Example, 0.42 E2. Strings. Example, a string. Characters. Example, #/C. Arrays. Example, #123, etc. Read, eval, print. The behavior of the interaction with the Lisp interpreter takes place in a read, eval, print loop. It is listed as below as: read a form and construct a Lisp object from it. Evaluate the input object to produce an output object. Print the output object using some print representation. Though a subtle but far-reachable consequence of the read, eval, print interpreter model is that all Lisp programs are nothing but Lisp data objects. For example, the Hello World program, print Hello World, is full of symbols and a string. Another aspect of read, eval, print is that it allows the interpreter to have different reader or printer representations for the same object. When this is true, the Lisp printer simply chooses one of them, but the Lisp reader can always recognize any of them. Next, we will consider evaluation, the second step of the loop. Evaluation. The read, eval, print loop evaluates input objects which produces output objects. Each kind of expression is evaluated in a different way. Lisp treats the symbol as a program variable and looks up its value in its lexical scope during the evaluation of the symbols. When lists are evaluated, a function named to a symbol is expected to be found out by Lisp as the first element of the list. Remaining elements of the list are evaluated to produce arguments, and the corresponding function is called with those arguments. Literals are also called self-evaluating objects. Introduction to Visual Prolog. Generally, a Visual Prolog program consists of 4 basic program sections. These are the classes section, the predicates section, the domains section, the goal section. The classes section is the heart of a Visual Prolog program. This is where you place the facts and rules that Visual Prolog will operate on during the trial of satisfying the program's goal. The predicates section is where you declare your predicates and the domains, types of the arguments of your prediction. You don't need to declare Visual Prolog's built-in predicates. The domain section is where you declare any domains you are using that aren't Visual Prolog standard domains. You don't need to declare standard domains. The goal section is where you commence the starting goal for a Visual Prolog program. Conclusion. In this chapter, we have covered the following in detail. Introduction to AI languages like Lisp, Common Lisp, Prolog, Visual Prolog, Artificial Intelligence Markup Language, Java Expert System, Java Expert System Shell, etc. Introduction to Prolog Programming. Anatomy of Prolog Program. Classes, facts, goal, variable, predicates and rules. Unification and backtracking. Lists and recursion. Arithmetic and comparison. Fail and cut predicates.